Hello, this is Wendy Lightheart, and today we're going to learn how to solve systems of linear equations by the addition method. The main idea behind the addition method is that we want to add the two equations together and eliminate one of the variables in the process. Let's look at a few systems. Notice what happens if we add these two equations together. If we add the x's vertically and then the y's and lastly the constants, we obtain a new equation of 8x minus 2y equals 7. But neither of these variables are eliminated, so this is not very helpful. One of these steps in the addition method is to rewrite the equations when necessary so that one of the variables will be eliminated when we add them. Let's try to add these two equations together. Notice that the variables and the constants are not lined up, so we'd have to rewrite this system before we could even begin to add the equations. Thus, another step in the addition method is to rewrite the equations when necessary so that they are both in the same form. Notice what happens when we add these next two equations together. See how the y's are eliminated? This is because the coefficients on the y's add up to 0. Let's look at the steps in the addition method. First, if necessary, rewrite both equations in the form ax plus by equals c. This will put both equations in the same form, which will line everything up nicely to add the equations vertically. The second step is to, if necessary, multiply either or both equations by appropriate non-zero numbers so that the sum of the x coefficients or the sum of the y coefficients is 0. The third step is to add the equations vertically to obtain a new equation. If you performed step 2 correctly, then one of the variables should have been eliminated. The fourth step is to solve the new equation obtained from step 3. This will give you a value for one of the variables, which is half the solution. To find the value of the second variable, we back substitute the value of the first variable found in step 4 into either of the original equations, and then we solve. The last step is to check the solution. Remember that a solution to a system is an ordered pair that is a solution to both equations in the system. Therefore, to check the solution, you must plug the values into both equations. If you obtain a false statement in either case, then you should go back and check your work, because that tells you that the ordered pair is not a solution to the system. Let's look at a few examples. Notice that the equations in this first system are not in the same form. Thus, we need to do the first step, which says to rewrite both equations in the form ax plus by equals c. Since the bottom equation is already in that form, we will leave that equation alone. We can add 2y to both sides of the top equation to get it into the proper form. Next, we should check to see if either variable will be eliminated by adding the equations we have so far. Notice that the x's add up to 7x and the y's add up to y. Since neither variable will be eliminated, we must multiply either equation or both equations by appropriate numbers so that the sum of the coefficients on one of the variables will be 0. The easiest variable to eliminate in this system is the y, and this is because the y has a coefficient of -1 on one of the equations. Thus, if we multiply both sides of the bottom equation by 2, then the y coefficients will be positive 2 and negative 2, which add to 0. By multiplying both sides by 2, our new system looks like this. Now we're ready to add the equations together. Notice that the y's indeed are eliminated, leaving us with an equation with only x. Our next step is to solve this new equation, which we can do by dividing both sides by 10. Thus we see that x equals 1. Now we need to find y, and we do this by back substituting into one of the original equations. Using the bottom equation, if we replace x with 1 and solve for y, we get y equals 0. Thus our solution to the system is the ordered pair 1, 0, since the x is 1 and the y is 0. Our last step is to check this potential solution. Remember that we must check it in both equations. Here's the top equation from our original system. We plug in 1 for x and 0 for y and see if this is a true statement. Since it's true, we know that 1, 0 is a solution to the top equation. Now we'll check it in the bottom equation. Again, we plug in 1 for x and 0 for y and see if this gives us a true statement. Because it satisfies both equations, it is in fact a solution to the system. Here's another system to solve. Our first step is to rewrite both equations in the form ax plus by equals c. However, both equations are already in this form, so we can skip this step. Notice that if we add the equations in their current forms, neither of the variables will be eliminated. Thus, the next step is to multiply either or both equations by appropriate numbers so that the sum of the coefficients of one of the variables is 0. Since none of the coefficients on the x's or the y's are 1 or negative 1, and neither of the pairs of coefficients are multiples of each other, we will need to multiply both equations by a number. Let's say we want to eliminate the x's, for example. If we multiply the top by 5, which notice is the coefficient on the x in the bottom equation, then that will give us 15x on top. We would need the bottom equation to have an x coefficient of negative 15. So we could multiply the bottom equation by negative 3. After we finish multiplying both equations by the appropriate numbers, we obtain this new system. And now we're ready to add the equations together. Our next step is to solve this new equation from step 3, which we can do by dividing both sides by negative 2. Thus we see that y is equal to negative 3. To find x, we back substitute y equals negative 3 into either of the original equations. Using the top equation, we plug in negative 3 for y and then solve to find that x equals negative 2. Our solution then to the system is the ordered pair -2, -3. Let's check this potential solution by checking to see if it is a solution to both of the original equations in our system. Here's the top equation. We plug in -2 for x and -3 for y and see if it is a true statement. Now let's check the bottom equation. We plug in -2 for x and -3 for y and see if this gives us a true statement. Because it satisfies both equations, the ordered pair -2, -3 is in fact a solution to our system. Recall that a system of two linear equations in two variables has three possible scenarios. These examples we've looked at so far both had exactly one ordered pair as the solution. Graphically, this means that each system was made up of two lines that intersect at exactly one point. However, a system might be made up of two parallel lines which never intersect. This kind of system has no solution. Or a system might be made up of two lines that are actually the same line. You can think of it as a line on top of itself, which means the lines share infinitely many points. Thus, this kind of system has infinitely many solutions. Let's look at how to determine that you have one of the last two scenarios when using the addition method to solve a system. In this example, since the bottom equation is not in the proper form, we first need to subtract 2y from both sides of the bottom equation. Now we need to determine which variable would be easiest to eliminate. Notice that both the x and y in the top equation have coefficients of 1 or -1, so either variable would be just as easy to eliminate. Let's try to eliminate the x's. Can you think of what number we might multiply one of the equations by to make this happen? Yes, if we multiply both sides of the top equation by -2, that would do the trick. This will give us a new system having x coefficients of -2 and 2, which indeed add to 0. And now we're ready to add. Notice that the y's will be eliminated as well, leaving us with 0 on the left side and -2 on the right. Usually our next step is to solve the equation from step 3. However, if both variables are eliminated, then we need to determine whether the resulting equation is true or false. If the equation is true, then there are infinitely many solutions to the system. And if it is false, then there is no solution. Thus, since the equation we obtained is false, this system has no solution. That's it for this lesson. Remember that you can always use either the addition method or substitution to solve any system. Some systems are easier to solve using substitution, and some are easier using the addition method. Once you've mastered both methods, you should be able to see which method will be easier and go from there.